So Tempo community call of May. How is Tempo related to Loki? We have an agenda item. Check that out. Tempo is a distributed tracing backend, whereas Loki is a logging backend. So in one sense, they're not really related at all. However, they are built onto a lot of similar technologies, as well as kind of connected through Grafana. So Grafana has a lot of nice integrations, as well as the Grafana agent to allow you to, log, create logs and create traces in a manner that allows you to kind of link those through Grafana, traces to logs, and logs to trace kind of jumps around. We currently use Loki internally as our kind of index into Tempo, because Tempo is a trace ID only store, but other backends work like Elastic or Splunk directly in directly in Grafana, and then really you could use anything, frankly. Any kind of backend where you could, any log backend where you can build a link with a trace ID works just fine for Tempo. Cool. State of exemplars. Yeah, that's a good one. To start today, though, I really want to introduce Kunrad, our newest Grafana Tempo developer. And why don't you jump in here real quick and just give us a quick introduction.
So hi, I'm Konrad. Recently joined Grafana Labs. I'm based in Belgium, so also speak Dutch. You can just talk English to me, of course. And yeah, also before working on Tempo, so I'm looking forward to get to know the community, get to know who's using Tempo, and contribute to it. There's a little typo in my name.
Welcome to the party, Conrad.
The party. Every day, that's right. Cool. So thanks, Conrad. Or sorry, I call you everything. I want to stick to something at least close to your name, Kunrad. Try it. Cool. We're glad to have you. Super excited to have Kunrad on the team, and I think it's going to be a great addition. Let's talk about 070. So we released that between the previous meeting and this. So let's just go over some headlines here. Some of the more important features that we added there. Let's see. I have the giant list up here. There's a ton of bug fixes. I won't go into all the details, but if you review that, there's a number of performance improvements. One notably that I really like and we've started to run internally, we marked it experimental, but we do use it, which is a compressed wall. And we use Snappy. The compressed wall is nice because it reduces disk I/O considerably because you compress before you write, but the exchange is it increases CPU and increases memory requirements of the ingesters. I think we were finding our internal bottlenecks are more related to disk or I/O throughput than they were necessarily the kind of the amount of CPU or memory we're spending in the ingesters. So we went with that trade-off, but for different people, this might be different. If you had very fast SSDs directly connected Tempo and some kind of like bare metal environment, then it might actually be quite a bit better to stick with non-compressed wall. Page-based access, index access sounds boring, but it's quite good, I think. And one of a great improvement here. So previously we were pulling like an entire index as one big blob, which really reduced the size of the indexes we could keep because once they get to a meg, 2 megs, 3 megs, it was a huge amount of data to pull for each block. But we've changed it so we've organized our indexes in terms of pages, and it'll pull 256K at a time. That's the default, I believe. And then it will only have to pull a much smaller subset of the full index, and it lets us grow our blocks way larger, which we're going to need as we continue to scale Tempo higher and higher. Those might be the highlights. I don't know if we did go to Go 116. That's probably worth mentioning. I don't know if there's anything else in here that is particularly interesting, but I think those are the ones that I was most interested in. Is there anything else the team remembers that is worth discussing? Take that as a no.
Maybe the drop of Jagger query. It was on this release, right?
Oh yeah, that's a great good point. Did I even note that in the things? Probably. We dropped the Jaeger query requirement. So we had this thing called tempo query, which is really based on Jaeger query. And it was kind of an annoying thing, mainly because it was just an extra piece that you had to run, and it was very confusing to people why it existed. Excuse me. But Grafana 7.5.x now and Tempo 0.7.0 directly support each other, and there's no need for this kind of intermediary. It makes our all examples much more simple. I think some of our examples still have it, but we're looking to remove those entirely. And Grafana can now query Tempo directly, which just makes everything easier, frankly. I think we're still going to keep the Tempo query piece around. It is nice, I think, to have a different way to query Tempo than directly out of Grafana if you don't want to use Grafana, but we're going to stop using it and kind of just like move it out of the examples and probably push people to stick with Grafana directly to Tempo.
Speaking of Grafana, the beta 1 for Grafana 8.0 dropped today. So exciting times.
Cool.
Joe, you guys also added the shutdown handler.
Oh, yeah. We use that to do a migration. So we had to move one of our Tempo clusters between Kubernetes clusters, one of our Tempo instances between Kubernetes clusters. And we had no way to tell an ingester to just completely flush all blocks to the backend. So we needed that. We needed a way to tell an ingester to completely push all blocks to the backend before we shut it down so we didn't lose any data. And that's why we added that piece. Zach, are you the guy running it in Fargate?
Okay. Yeah.
Okay.
Yeah. So I'm now having to figure out having to trigger that on shutdown of the containers. So I'm probably gonna have to like rebuild your images a little bit more than I already was, so that I can run that as a pre-shutdown. Fargate unfortunately doesn't give you any control over that. It's just they send a term and that's it.
So I don't think it would be too difficult to add a config option to the ingesters to just do that on shutdown. Like that'd be the default behavior on shutdown. We wouldn't run it that way, but for people who are in an environment where that made sense, it would be fine. It would make shutdown take a long time, but you would be welcome to run that.
Yeah, that'd be cool. I mean, I need the same thing on Loki because I checked in with them and they said like, oh yeah, we have the same thing. When we shut down, we're not actually flushing all the logs. It's like, oh. So I've probably been losing a little bit of data every now and again.
Right. Cool. Yeah, I'll add that as an issue. It's easy enough to add as an issue, and then we can kind of see if we can spend some time on it. I don't think it'd be too difficult.
There is one thing where the blocks that would be flushed won't be immediately queryable. I mean, I think that's more of a like cost benefit, like it's worth getting the stateless ingesters, right, without persistent volumes, but you can have maybe gaps in querying. That's, something that we would hope to address, if we change the way the blocks are pulled and things like that. But I think I'm not sure that's something that we could resolve like short term though. Yeah.
So I'd have to wait for like the compactor run.
Just for the queryers to repoll the blocks, like if they pull every 5 minutes, there would be that, the ingester will flush the block and then go away. Normally the ingesters hang on to the blocks and, respond to queries for that data because they're the only pod that would know about it. So, for a few minutes until they, repoll the blocks, those traces that were just flushed wouldn't show up. Yeah. But I think that's probably worth it. I think for use cases like this, like it's probably sounds better to have that than maybe like the pre-shutdown API call.
Yeah, for my case, the only time anybody's like live querying as traces are popping up is when I'm checking to make sure that it works in a demo or something. Otherwise, yeah, minutes to hours later is fine.
Cool. Cool. Marty's got some stuff in here. Marty, do you want to do these?
Sure, yeah. I think there were a couple things maybe in 07 to call out real quickly. There was a Kafka receiver and a couple breaking changes. We don't need to go through them, but just to be aware, like from 0.6 to 0.7. Yeah.
That's right. We're going to keep that 0 up front as long as possible.
Right.
Here, let me link the change log. That's a good idea. I was kind of just staring at it a second ago. Marty, do you want to do yours, or I was going to talk about Zipkin some?
Yeah, go for Zipkin. That sounds good.
Okay. So we've always supported ingestion of Zipkin, but we don't use Zipkin. So there was a surprise, I suppose, when we actually did have a customer who started using it. But Zipkin purposefully duplicates span IDs between the client and the server. So when the client reaches out, it creates a span and it passes that span ID. And in Jaeger and OpenTelemetry, a new span is created on the other side with a new span ID. But in Zipkin, it duplicates that purposefully. It uses the same span ID across as on both sides. The negative of that is we wrote a bunch of code that assumed a span ID would be unique, basically, in a trace because it was an ID. But it turns out to be not correct in Zipkin. So we had 2 small changes. It actually wasn't as bad, maybe, as I thought when we first heard about this, or the customer first started having this issue. One was kind of, we have this combined trace logic that has this assumption of unique span IDs, and that's been fixed. And the second is on query, we dedupe. So we search the trace for spans that have the same ID, and then we dedupe them, and we create a new span ID on the other side. And this logic is straight out of Jaeger. So we also found this code in Jaeger because Jaeger supports Zipkin, and we took their code and just adapted it for OpenTelemetry because they use Jaeger internally, of course, and we use OpenTelemetry. So if someone was using Zipkin, I think it's got a little bit less popularity than maybe Jaeger or some of these other pieces. You may have been seeing this, and it should be fixed. It's in the tip of main, but it has not been cut. So the next release will have these fixes. Cool. Marty, do internal scale. That's next on my list.
Sure. Yeah, I think this is always kind of fun to go through as we kind of work on making Tempo more performant and scalable. And also, I mean, we get discussion for things like, how many different pods or different components should I run? And it's hard to say because workloads vary so much across clusters. So this is just kind of going through an internal cluster that we have, which is our monitoring cluster. Yeah, so I mean, I can just go through this and maybe talk about thoughts on some of these things. So currently we're ingesting 1 million spans per second, and that's around 150 megabytes to the distributors per second. So we have plans to go, I mean, I guess our goal is probably 3 or 5 million spans per second and then higher, but 3 or 5 million would be kind of like the next step. Probably we might even be able to get that with the current design. It's not maybe worth us sampling that much just for our own internal testing. But yeah, so just to get a sense of the amount of pods, we run 24 distributors, and they kind of have smaller memory limits of only 3 gigabytes. The ingesters we run the most of, so there are 40 of those, and because they hold on to a lot of traces and a lot of spans, the memory limit for those is quite large, 15 gigabytes. They cut blocks at 700 megabytes, and that's snappy, so that's after compression. So I think before compression, that was somewhere around 3 gigabytes, I think, just to get a sense of how often data is cut. And I think each ingester is cutting a block every couple of minutes. They have 50 gigabyte persistent disks. Now, the reason for that is they don't actually need that much storage, but it's in order to get enough bandwidth, right? So the bandwidth for the disk scales up with the size. This is in in Google Cloud. So I don't think we're running into any bandwidth limits right now, but I think we're close, right? So it's probably something else we'll look at. So compression for the wall was really important there because that cuts down on just how much data is being written to disk at once. For queryers, so we have 25 queryers and 2 front ends. So the queryers are kind of like the pods that are doing the work, and the front ends are serving the API. I just got here, our query P90 for looking up a trace is somewhere between 2 and 5 seconds. So most of the time it's 2 seconds, but we have occasional long tails over time that are around 5 seconds. P99 is worse. I think maybe it's more like 10 seconds. I would just go and put that in here. That was something maybe something like that. We had 36 compactors. I didn't get any of the configuration options, and I'm not sure that we really need that many, but we did find that it's good to have that many. I think compacting is still something that we're working on tuning, and determining the proper number of. Yeah, Jody,
Yeah,
do you want to jump in here?
the compactors are relatively small. They're like a
Yeah.
few gigs of memory each and
Yeah.
one CPU. So they're not doing a lot of work. I think most of our pieces are smaller compared to, say, Cortex or Loki, but I don't really know. Also, I had no idea with 36. I would have guessed like 10 less than that, maybe. I should have known that.
I think, when we increased the sampling rate to 1 million scans per second, the block list was growing quite a lot. I think it was higher than this for a while. And so I would say compactors are still in progress thing, being tuned, right? There was the compaction time window that we reduced, I think, to 15 minutes, things like that. Yeah, the maximum block size we increased, and then we were running quite a lot. I would say at any given moment, some of them are idle though. Yeah. Yeah, so for totals, that's around 210 CPU at any given one moment, around 353 gigabytes of memory. And there's more than just this. So that's in that entire Kubernetes namespace. There's a couple of things else that we run, like just sidecars and things, but that's the total. So, I mean, I was thinking about sharing the dashboard, but it's kind of dense, and I'm not sure. I would have probably just talked about these same things. I thought it would be clear to show this, though. So yeah, cool.
Thanks. Definitely. At 1 million scans a second, we're actually at 1.5 million for a while. Sometimes it's hard for us to track what's going on in our different applications to know why we're growing or shrinking. So for a couple days there, we were sitting at 1.5 million, and it was fine. Also, I always cringe at the 210 CPU. It just seems like so much. The good news, though, is we're going to reduce that quite a bit. There's a PR in now in Maine, although it broke everything, that significantly reduces the CPU usage of the ingesters, about 70% reduction, which is really exciting because of the 200 CPUs, I think like 150 of them are ingesters. Like it's almost all ingesters, so, or the majority is ingesters. So this will be a huge reduction. And I wanted to get this in before we started pushing to that 3 to 5 million Marty was talking about.
Oh yeah, I forgot to cover this part here, but we can just quickly. So we have 2-week retention, and that's about 56 terabytes of compressed data, 25 billion traces. Yeah.
Yeah.
So yeah. You know, I was thinking one metric that I'm not sure Tempo has, but that would be interesting, was how many live traces are on each ingester at a given moment. I think that's another thing where comparing across workloads would be useful. Yeah, just mentioning it.
Yeah, we don't have that, do we? I guess well, I was trying to figure out if you could derive that from other
Yeah, we
information.
have traces created.
Right.
But I'm
And
not sure there's any way to tell. Yeah.
And we have traces per second ingested.
Yeah.
Yeah, I don't know. I don't even know how long an average trace lives. We would need that histogram because we cut traces, I guess, 10 seconds. Because our trace timeout's 10 seconds. It would be something like that. 10 seconds times traces per second would be close. I'm not sure.
Right.
Okay, cool. Thanks, Marty.
So, yeah.
I also chucked the link to the reduction PR into the doc. There's some really juicy graphs in there. On our little test bed, I had 0.1 CPU for the ingesters, and then we're down to almost 0.25. So just a huge reduction in CPU usage. Basically, what we did is not marshal proto. So we marshal at the distributor level, and then we pass just bytes, like blobs of bytes to the ingester, which stores it directly into the backend, and we only remarshal it if we have to, like if you query it, basically. So we think that's going to be a huge improvement. Now, it basically broke a lot of stuff that we're working out right now. And I really wanted to have this in our operations cluster today for this meeting, but it didn't work out. So I think the team's deciding between one of two paths going forward, and we have PRs up for both of those, but we'll figure that out. Cool. Marty, you're up next. You can tell us about exemplars?
Sure. So, I mean, I was going to talk about just kind of the current state of exemplars. Like there's been some cool development. But I'm wondering if we should talk about what exemplars are or anything like that, or maybe not. Maybe we'll just skip that. Yeah.
I don't know.
Just got to chime in here from the Grafana side that My colleague Jita is working hard on exemplar documentation because they're a big thing in Grafana 8 under our tracing updates. So stay tuned. Wondered if you guys had anything to speak to on that from the tempo side.
Marty, I'm getting paged. Why don't you handle that?
Sure, yeah. I mean, as far as I understand, like I think they work well in 7.5.5. And so that's the version I've worked with. I'm not aware of what the changes are in 8 though. Yeah. Cool. Yeah, let's do. On a previous community call, we kind of walked through exemplars and kind of a demonstration of them. So I think we could look that up if anyone is interested. I guess I would say they're kind of still experimental and in progress. So that is why, like this is, I'm not sure that this is something that anybody would put into production today. But just to talk through the current state of exemplars. So on the previous community call, the news was Prometheus 2.2.6, which was a very basic introductory support experimental. And now, actually, just recently, as of yesterday, Prometheus 2.2.7 has released with extended support, more things for exemplars that are going to be required for like the other use cases that we want, things like Grafana Cloud, and if you were to run this in your own cluster. So what is new is in Prometheus 2.2.7 is it will now store so it always would scrape the exemplars, but now they will also be written to the write-ahead log. And what that does, previously the exemplars were purely in memory. So if the pod was lost or restarted, the data would be gone. But in the write-ahead log, it was able to recover some of the data. And I'm not sure, I can't remember exactly how long those write-ahead logs are retained, so that they're not permanent. This data is still not part of like the long-term, sample storage, but it will usually is on the order of a couple of hours, so we'll be able to recover some exemplar data. Additionally, it also will now send the exemplars to a remote write target, and so the goal for that is there are other tools that could do this, but currently we're working on receiving that data in Cortex, and so that would be meaning that we are working on the ingest and query path for exemplars in Cortex. So that would be a downstream target of Prometheus. Prometheus would be running and scraping the exemplars in your cluster, and then sending it to a Cortex backend. Yeah. Let's see. So I was mentioning 7.5.5, and so for querying exemplars, if you have Prometheus, you can query exemplars. I would go with 7.5.5. There was a small, like there was support previously, I think 7.5.3. Is where it became like the stability was there. But I think in 7.5.5 there was a small UI fix, so I think I would go with that one too. And another thing, I think Mario, I think we were talking about this recently. So another thing in progress is exemplar support in Grafana Agent, right? And so Grafana Agent makes use of Prometheus, and so now that this has been merged in release, we can bring that functionality into Grafana Agent. And that will also be able to scrape and remote write exemplars. And I'm not sure if that's actually, yeah, do you want to talk about that for a second?
Right. I mean, I don't have much news. Yeah, it's not yet on the agent, but it's like the next item on the list. Yeah, so yeah, stay tuned to agent PRs.
Cool. Cool. Thanks, Marty.
Yep.
We're there, right? It's almost done.
Yeah, I mean, the query path, there's a PR for the query path in progress now. And then I think after that, yeah, I think it will be coming to Cortex soon.
Nice. Cool. Cool. Thanks. So member list is next. We've had some discussion on member list. I was within seconds of ditching it. In fact, I told the team I was going to ditch it, but we stuck with it because the community really wanted it. They like it. And so we have since made some tweaks to our settings and found a lot of stability. So I'm glad that people pushed me to keep it. I was about to give up. But what you see there in the doc is our current settings. And since we've had these settings, our issues with like the common problem was like unhealthy compactors. Compactors just sitting in there forever. They're impossible to forget. We couldn't figure out why. Since we've made these changes, we've not seen that at all, I don't think. I can't even remember the last time we had to sit there and smack forget on a compactor page, praying that it would go away, and getting really frustrated, and going to extreme measures to get rid of it. So I would recommend these settings if you're using member list. I think we found them very stable, and please give us feedback if you don't, so we can continue to work on these. Basically, I think what we've learned is that there are a lot of settings. We probably can find stable settings regardless of cluster size, at least up to ours, Cool. Mario? Is Mario here? Oh, hey,
Yep.
Mario. There you are.
Yeah, so exciting news from the agent. We have a couple of new features that we wanted to talk about. The first one is auto login. So like running a distributed system, system with distributed tracing, it's very powerful, but also has a lot of challenges. One of those is trace discovery. Well, as you may know, Tempo doesn't offer like a direct tool or way to just find the trace based on different parameters. So you usually have to leverage other tools like login, metrics, and the like, but maybe your instrumentation, your login or metric doesn't support exemplars like we were talking about, or login, or your login doesn't support injecting trace IDs. So we thought, maybe there is another way, like another tool for trace discovery, and that is automatic login, which is in the agent, which you can think of it like just a tracing pipeline. It will enabling this feature will log a well-formatted log line for every span, root span, or process, or any combination of those that passes through the agent, through that tracing pipeline. And what this allows is automatically building a trace discovery system through the logs, and also building metrics from the traces. At the moment, it just supports Loki. So what it does is uses a Loki instance within the agent, which you can think of it of just a Promtail client. So it pushes logs to Loki, and then you can use Loki to find those traces. I have a live demo prepared, but if you have any questions or comments beforehand, we can address them. If not,
Cool. Let's see this demo.
Right. Well, I have it. It's been running for quite some time, so hopefully it hasn't crashed. Can you see my screen?
Yep.
Awesome. Right. So I'm just running the Docker example from the agent as it is in main, and we have automatic login enabled for all three type of kind of traces you can log for, which are spans, again, root span, and processes. So yeah, these logs are logged with label, which in this case is Tempo. You can override that, and then you can select any of the three. For instance, we can search for just, let's see what spans are being processed in the agent, and there you have it. You see the logs are just pairs of key value, like key value pairs, which describe tags properties from the spans. And then what is cool is that, well, sorry if you're hearing my keyboard. I'm one of these people with mechanical keyboards. That you can search, like do interesting searches for these traces that you couldn't do otherwise. So I'm just formatting the log line, and I'm searching for traces which have a duration longer than 1 second. And then where here the field, then maybe I want to message that also have that are also errors. Nice. And then, yeah, we have all these traces. And to see them, the Grafana folk already built a nice integration here. You can just open the log line and click on tempo and watch the trace and see what's going wrong with your service. Yeah, this is the quick demo. Yeah, as I said before, at the moment, this only supports using Loki. We're looking to also probably add in support to just log into the standard out. Yeah, and well, just by using the tool, hopefully we'll come up with more improvements.
Question, am I correct in assuming that I can add Loki labels based on like the source that it came from? Okay, great.
Right. Yeah, it has all the Loki capabilities. So you can use all the Promtail client configuration and yeah, and like constant labels. Yeah, well, I can think of more, but sure.
Cool.
Yeah, so very powerful tool. All right, and the next feature is that we added remote write to span metrics. So as we showed last week, we introduced metrics generated from the spans, again, in the agent, so in this tracing pipeline. But how they were being exported, the metrics, was just by the Prometheus exporter from the auto collector, which basically just exposed a metrics handler, which you would have to scrape. So another option that we have introduced is instead of exposing an exporter, maybe we can use the remote write capabilities of the agent. So now you can use a Prometheus instance within the agent. It's like the very same case as for a Loki instance from the previous feature, and directly push to any Prometheus like backend, like Prometheus Cortex or anything. Yeah, and then finally, well, we have just mentioned it, like the next item on the list is adding support for exemplars in the agent. Now that pull request has been merged to the upstream to Prometheus. Yeah, and hopefully that will open many doors for that feature. And well, that's it for me.
Cool. Thanks, Mario. Cool. Well, I think that's roughly it for the agenda we had. If there's any other questions or any other points of discussion that people would like to cover, feel free to ask or put it in the document or whatever works. I see Ananya made it. Are you there, Ananya? Or are you busy?
Hey, Joe. Hey, everyone. Just barely making it. Can you even hear me?
Yeah. Can you hear me?
Yep. Yeah.
Okay.
Yep. I saw Mario's demo. That was pretty cool, man.
Yeah.
Thanks.
I think I'm excited about the span logging. I want to see it in. I want to compare it to other metrics that we have. I want to see what it tells us about what we're ingesting. I think we'll learn things with auto logging.
Yeah.
Cool. Well, if that's it, we can go ahead and call it. We're a little early, but no big deal. Everybody enjoy your whatever week's left, and we'll see you in a month, I suppose. And yeah, feel free to jump in on the Slack channel or add issues to the repo. There's a community forum as well to ask questions, and we do our best to answer all of these quickly and to engage people through all of them. So feel free to kind of connect to us whatever makes sense, whatever way makes sense to you. Cool. All right. Everybody take care. We'll see you when we see you.
Bye.
Bye.
See you.
Bye.